An introduction to additive manufacturing. At the end of this lesson, you will be able to define additive manufacturing, list the materials to be used in additive manufacturing, explain the generic process of additive manufacturing, list the different types of additive manufacturing processes, list the applications of additive manufacturing. 3D printed house. Three-dimensional printed houses. These houses have been accepted by people all over the world. On 6th July 2018, Nordini and Noria Ramdani, living in Nantes, a city in France, became the first in the world to move into 3D houses. These 3D houses are designed as a social prototype and constructed over an area of 1022 square feet. Let us get into the construction part of this house. At first, house was designed in a studio by a team of architects and scientists and then programmed into a 3D printer. The printer is then brought to the site of the home. It works by printing in layers from the floor upwards. Each wall consists of 2 layers of the insulated polyurethane with a space in between which is filled with cement. This creates a thick insulated fully durable wall. The windows, doors and roof are then fitted. Also, its construction time is approximately 54 hours and overall construction cost is reduced to 25% of traditional construction. Being inspired by the technology, faculty and alumni of the IIT Madras built its first successful 3D structure. This type of printing objects is called additive manufacturing. Today, we will discuss what is additive manufacturing and how it is performed in detail. Materials to be used in additive manufacturing. Let's start with the definition. It is defined as the process of joining materials to make objects from 3D model data, usually layer upon layer, as opposed to subtractive manufacturing methodologies. It is possible to create 3D objects using different materials such as thermoplastic polymers, metals, ceramics, and biochemicals. Thermoplastic polymers include acrylonitrile butadiene styrene, that is ABS, polylactic acid, that is PLA, and polycarbonate, that is PC. Metals include precious metals that are gold and silver, and strategic metals like stainless steel and titanium. Ceramics include zirconia, alumina, and tricalcium phosphate. Biochemical materials include the use of hardened material from silicon, calcium phosphate, and zinc. Additive manufacturing. Additive manufacturing follows generic process starting from virtual CAD description to the physical resultant object. Step 1. CAD. All AM parts must start from a software model that fully describes the external geometry. This can involve the use of almost any professional CAD solid modeling software, but the output must be 3D solid. Step 2. Conversion to STL. Every AM machine accepts the STL file format, which has become default standard, and nowadays nearly every CAD system can produce the output in STL format. This file describes the external closed surfaces of the original CAD model and forms the calculation basic of the slices. Step 3. Transfer to AM machine and STL file manipulation. The STL file describing the part must be transferred to the AM machine, where the general manipulation of the file is carried out to make it correct size, position, and orientation. Step 4. Machine setup. AM machine must be properly set up prior to the build process. Such settings would relate to the build parameters like material constraints, energy source, layer thickness, and timings. Step 5. Build. Building the part is mainly an automated process, and the machine can largely carry on without supervision. Only superficial monitoring of the machine needs to take place at this time to ensure no errors have taken place, like running out of material, power, or software glitches, etc. Step 6. Removal. Once the AA machine has completed the build, parts must be removed after the removal of interlocks. Step 7. Post-processing. Once the parts are removed from the machine, it needs to be cleaned up before they are ready to use. Step 8. Application. Parts created are now ready and acceptable for usage. Types of additive manufacturing process. Types of additive manufacturing processes are material extrusion, directed energy deposition, material jetting, binder jetting, sheet lamination, vat photopolymerization, and powder bed fusion. Let us discuss them one by one. Material extrusion. Spooled polymers are extruded through a heated nozzle mounted on the movable arm. Nozzle moves horizontally, while the bed moves vertically, allowing the melt material to form layers. Proper adhesion between layers occurs through precise temperature control or the use of chemical bonding agents. Directed energy deposition. In this method, material is deposited on the surface from any angle due to 4 and 5 axis machines and is melted upon deposition with a laser or electron beam. Material jetting. In this method, the material is jetted onto the build surface or platform, where it solidifies and the model is built layer by layer. Material is deposited from a nozzle which moves horizontally across the build platform. Layers harden as they cool or are cured by ultraviolet light. Binder jetting. In this method, powder material is spread over the build platform using a roller. The print head deposits the binder adhesive on top of the powder where required. The build platform is lowered by the model's layer thickness. Another layer of powder is spread over the previous layer. The process is repeated until the entire object has been made. Unbound powder remains in position surrounding the object. Sheet lamination. In this method, sheets of building material are placed on the build platform and it is cut using laser beam. Laser cut sheets are joined one after the other using adhesive or welding to form three-dimensional objects. Vat polymerization. In this method, liquid photopolymer resin is kept in the container. An ultraviolet light is passed into the resin to harden the resin wherever required. Also, the platform moves downwards after each new layer is cured. Powder bed fusion. In this method, the metal powder is spread over the build platform and a laser or electron beam from the source melts the fused material powder together to form the desired 3D object. Powder bed fusion processes includes direct metal laser melting, that is DMLM, electron beam melting, that is EBM, directed metal laser sintering, that is DMLS, selective laser melting, that is SLM, selective laser sintering, that is SLS, and selective heat sintering, that is SHS. Applications of additive manufacturing. Additive manufacturing is helpful in producing aerospace parts with lightweight and complex design. 3D printed leg for physically challenged. Lightweight rims for the racing car wheels. Conclusion. Thus, we can conclude that if 3D printing is an option for constructing homes and offices, we can eradicate the practical difficulty, that is, formation of complex shapes and curvatures that arise in traditional construction. Summary. In this lesson, you have learned that additive manufacturing is the process of joining materials to make objects from 3D model data, usually layer upon layer, as opposed to subtractive manufacturing methodologies. Generic process followed by additive manufacturing. Materials used in additive manufacturing are thermoplastic polymers, metals, ceramics, and biochemicals. Types of additive manufacturing processes are material extrusion, directed energy deposition, material jetting, binder jetting, sheet lamination, vat photopolymerization, and powder bed fusion.